Okay, so this time we're going to take what we just worked with in terms of degrees, and we're going to start with degrees on our unit circle, and we're just going to do that quickly. So what I would like to do on this next one is we're going to work with what are called right here radian measures of our angles. Radian measures are going to be important as we move forward and graph like our sine, cosine, tangent functions. And again, all these special angles, it all comes from the understanding of this unit circle. Okay, so we said for degrees, we're going to start on our positive x-axis. That point where the unit circle intersects the positive x-axis is 0 degrees. And then we go all the way around our circle in special angle pairs. So we have 30 degrees, 45 degrees, 60 degrees, and then this top angle is 90 degrees. Okay, so then we kind of highlighted, I'm going to do this again. Multiples of 45 degrees are in the middle of each quadrant and also at the top, in the bottom, and the left and the right. So in the middle and on the quadrants. The rest of them, this is just how I prefer to do it, the rest of them are all multiples of 30. So multiples of 30 are here, 30, 60, and then at the top, 90. And then these missing ones are multiples of 30 and on the quadrants again, okay? So all of those are multiples, and that's how we find the rest of our angles and degrees. Okay, so then I just kind of think to myself, from 90, I add 30, I get 120. And then I add 30 again, I get 150. Add 30 again, I get 180. Add 30 again, 210. Add 30 again, 240. And then, 240. And then, that looks weird, sorry. And then add 30 again, you get 270. Add 30, you get 300. And then 330. And then 360. Okay? And then our red angles there for 45 degrees, if I add 45 to itself, I get 90. If I add 45 to 90, I get 135. Add it again, you get 180. Add it again, you get 225. And then 270, and then add 45 again, you get 315. If I add it again, I know I should be at 360, which I am, okay? So it's kind of a review of finding all the degree measures all around our circle. What we're going to do now is find radian measures. So again, I kind of explained what radians are. I just want to kind of focus on how to get our radian measures. This is the big idea right here. We're going to multiply each of our degree measures, or each angle, by pi over 180. That is our radian, or I guess degree to radian conversion, okay? So I'm going to multiply by pi over 180. So I still start with 0. And if you think about like going around the circle, we call like the distance around the circle is circumference. The circumference of a circle is 2 pi, okay? So we start at 0, and just like before, if we go all the way around full circle, we're going to end at 2 pi, okay? That's just the circumference of a circle would be 2 pi. Okay, so now we're going to find all of these special angle pairs between there. And I'm just going to start with 30. So if we start with 30 degrees, we're going to multiply 30 by, up here, our conversion is to multiply by pi over 180, which I highlighted in red. So we're going to start with 30 degrees, and I'm going to multiply by pi over 180, okay? If I do that, if I have something that's not a fraction and I'm multiplying by something that is a fraction, I'm going to like put that over 1. And then I have 30 pi over 180. That would reduce to, 30 goes into 186 times. So that would reduce to pi over 6, okay? So this first angle in radian measures is pi over 6. I don't care, I hate to say this, but I don't care so much that you understand what radians are. I just want you to be able to find them at this point, okay? Apex will kind of fill in some of the gaps for you. I just want to make sure we explain and you know how to find all these parts of the unit circle. Now, I'm going to do all my multiples of 30 first. So I'm going to skip that 45 degree angle. And then I kind of think of this the same way as we thought of it with degrees. So this next angle is a multiple of 30. So this is like 1 pi over 6. If I multiply that by 2, I would get 2 pi over 6. Or 2 pi over 6 reduces. 2 pi over 6 would be 1 pi over 3. okay? So let me erase a couple things here. So this is going to end up being pi over 3 is my 60-degree angle. Again, all I did is I took this, pi over 6, and I multiplied it by 2. Because it's 2 times 30 is 60. That means 2 times pi over 6 would be 2 pi over 6 or pi over 3. So we're reducing them. You know what? That might actually be helpful. Let's go through first and just say this is 2 pi over 6. So it's my first multiple of 30 degrees, which would be 2 pi over 6. That would mean this is 3 pi over 6. My next one would be 4 pi over 6. So it's the fourth multiple of 30. My next yellow one is 5 pi over 6. It's the fifth multiple of 30. Hopefully that's making sense. This one then, oops, sorry about that. This one is 6 pi. Keeps moving on me. 6 pi over 6. The next one would be 7 pi over 6. And then 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. And then this last one, technically, I'm going to write it off to the side here, 12 pi over 6. We already said would be 2 pi. So 12 pi over 6, that does reduce to 2 pi. 6 goes into both of those, 2 times on the top, one time on the bottom, okay? So now I would just say we want to reduce all of our fractions. So you have all of those you have almost all of the radian measures now. You just need to reduce them. So pi over 6 is reduced. 2 pi over 6, we kind of talked about a second ago, that's going to reduce to pi over 3, okay? 3 pi over 6, that reduces to pi over 2, because 3 goes into both of those. 4 pi over 6, I think 2 goes into both of those, so 2 pi over 3. 5 pi over 6 does not reduce, it just stays. 6 pi over 6, the 6's cancel, and you just have pi. 7 pi over 6, that does not reduce. 8 pi over 6 does reduce, 4 goes into both of those, so, 2 goes into both of those, so it would be 4 pi over 3. 9 pi over 6 would reduce, 3 goes into both, so 3 pi over 2. 10 pi over 6 does reduce, 2 goes into both of those, so 5 pi over 3. And then 11 pi over 6 does not reduce. We already reduced 12 pi over 6, okay? So you have your radian measures. They're all going to be in terms of pi all the way around your circle. Okay, so then the last one is your 45-degree angle. So 45 degrees, if I start with 45 degrees and I multiply by my conversion, which is pi over 6, got pi over 6 in my head, pi over 180, then if I multiply that, that's 45 pi over 180. 45 goes into both of those, it ends up being pi over 4. So let's do this in a different color. So this is pi over 4. If I multiply that, again, 45, the first multiple of 45, like 45 times 2 would be 90. So this is technically 2 pi over 4. Well, 2 pi over 4 is already reduced for us. That's pi over 2. Then the next one would be 3 pi over 4. That's already reduced. We don't have to reduce these ones. The next one would be right here. Kind of skipped that, sorry. The next one would be right here. This would technically be 4 pi over 4. That also reduces to pi. So that's already reduced for us. We don't need to do it again. The next one in the middle here is 5 pi over 4. The next one is 6 pi over 4, already reduced. And then 7 pi over 4. And then the last one would be 8 pi over 4. Again, we already have that reduced into 2 pi. Okay, so I'm going to erase these arrows. So you can kind of see everything that I have circled, including 0, which I did not circle. Those are all of our radian measures. So when we circle back around and review this at the end of everything I'm going to show you with the unit circle, we will add those back in, okay? I would like to show you just real quick, kind of like we did before with 30 degrees. So all of these angles that are 30-degree reference angles are pi over 6s. So if you look at 30 degrees as pi over 6, 150 degrees is the next multiple of pi over 6, or like the next one where it reduces down to pi over 6. So 5 pi over 6, the next one is here, 7 pi over 6, and then the last one is here, 11 pi over 6. Same thing with 45. 45 is pi over 4. The next one that ends in a fraction with 4 is right here, 3 pi over 4, and then 5 pi over 4, and then 7 pi over 4, okay? And then your last one you can kind of see right here, 60 degrees. 60 degrees is a fraction with pi over 3. So then the next 60-degree angle is still 2 pi over 3. The next 60-degree angle is 4 pi over 3. The last 60-degree angle is 5 pi over 3. And then technically the last ones, this is kind of harder to show. The last ones, let's do a different color, blue here. Right here. So your quadrant angles are pi over 2. So pi over 2, and then 2 pi over 2 would reduce to pi. 3 pi over 2 is just 3 pi over 2. 4 pi over 2 would be 2 pi, okay? So there's lots of multiples within this. I know that kind of looks confusing, but hopefully you can see kind of the point is to, every time we do one of these, they're all multiples of each other, okay? So we just did multiples of 30 degrees from our radian measure, and then we reduced them all the way around. Then we did multiples of 45 degrees and reduced them if possible, okay? All right, and then we will move on to ordered